Okay, we're going to do this using our calculator just like I did in the last problem, and then we're also going to do it showing you how to do it algebraically as well on some of these. So 14, we want to do the limit as h approaches 0 of 3 plus h cubed minus 27 all over h. And so I want to get smaller and smaller values of h, so I'm going to put h, and I'll put, this will be 3 plus h cubed minus 27 over h. Okay, and what I'm going to do is I'm going to put this function in my calculator just like we did in the last problem. So I'll go to y equals, and I'm going to get, you just got to make sure you get the right parentheses in here. 3 plus x cubed minus 27 all divided by x. We're using x instead of h, of course, because that's our variable in our calculator. Table set should stay that way. Second table. So smaller and smaller values of h. And this already has 0.1, 0.01, 0.001, 27.9, 1, 27.09. If any of you guys know a way to keep this up when I do this, that would be great. I would love to know that. 27.009. I think you see a pattern. So as the h gets closer to 0, this gets closer to 27, which means this limit is 27. Alright? So we'll actually, in class, we'll take a look at doing one like that algebraically, because I want to talk to you about cubing binomials like that. So 16, we're going to do the same thing. The limit is h approaches 0 of 7 to the h minus 1 over h. So let's do h and 7 to the h minus 1, to the h power over h. So we'll do 0.1, 0.01, 0.001. Look over here. And if you want to do this by hand, you're certainly welcome to do it by hand. So it'll be 7 raised to the x. Careful to move your cursor down, otherwise it keeps it in the exponent, which I'm sure you guys already know that. H. And I'm going to go second table. And there we go. 2.15. So I can't remember all these numbers. 1.965. 1.948. And it doesn't look like it's going anything that I can recognize right now, so let's just keep on going. 0.00001. 0.00001. 0.00001. Okay, well, to 4 decimal places anyway. It's going to 1.9459. Okay, and we're going to learn later on, so as h goes to 0, how can we get that number without just making an approximation on our calculator? We will get there, rest assured. Match the slopes labeled on the, for number 18, labeled on the curve in 2.8 with the given slopes. Okay, so slope is negative and positive, big numbers. Which is the most negative or the steepest negative slope? Is going to be this guy right here. So that's going to be f. Then the only other slope that's going down is going to be like that. -1, so that'd be c. 0 slope is the tangent line. The slope of that tangent line is e. Remember, and I should have said this a little more clearly here, the slopes of the curve are the slopes of the tangent line. That's how we define the slope of this curve at that point is the same as the slope of that tangent line. Okay, now we got 3. Which one's the steepest? 2. That's going to be D. Then looks like 1 will be B, and the flat, or the little smallest positive slope would be A. All right. And then lastly, number 19 on this one. For the function shown in 2.9 down here, what points is the slope positive, the slope negative? Okay. Slope positive, slope negative. And then it says, at which label point does the graph have the greatest slope and the least slope? Okay, so positive slopes. A, D, negative slopes, C, and F. And it looks to me like B and E are right at the top, so they're going to have zero slope. Zero slope. In other words, the slope is actually equal to 0. B and E. And which is the largest positive? Well, between A and D, which one looks steeper? A is the steepest. Well, I'm saying steepest, which it is, but this would be the largest of the two. And between C and F, C is that guy and F is a little bit longer. So let's go. And there's my son calling me, so I'll finish this off. That is the sorry about that. And E or F would be the largest negative slope. Okay. Largest negative slope. Okay, there you go.